are the two initial conditions? T is equal to 0. What is y? Read the problem. Y 0. And the velocity y dot, if nothing is mentioned, I will take it 0. And now substitute the first initial condition at t is equal to 0, y is y0. See what you get. Okay, if I substitute t is equal to 0, y is y0 in equation 2. So y0 is equal to e raised to 0 is 1 into bracket a, also is again 1, and sine 0 is 0. And therefore I get a is equal to y0, the first constant. Got it? Now let us substitute second initial condition. At t equal to 0, y dot is 0. Where you will substitute this equation? First of all, you have to derive equation of y dot. So taking derivative of equation 2, derive it and then you can substitute for second equation. This was the derivative. Now you have to use the formula of derivative u into v. Is it? So derivative of e raised to minus alpha t is minus alpha e raised to minus alpha t. That is du into v as it is first. Plus now u as it is e raised to minus alpha t. And now we have to take derivative of the bracket. So minus a beta sin beta plus b beta cos beta. Am I right? Now you substitute at t is equal to 0, y dot is 0. So you get 0 is equal to plus alpha into 1 into bracket is A plus e raised to 0 is what? Again 1 into A into E. And therefore you will get E is equal to alpha upon beta into A. B is equal to take this A alpha on this side. So it will be alpha upon beta into A. And A is y0. So alpha upon beta into y0. Okay. And now you can substitute A and B in equation 2. So say substituting A and B in equation 2. I can write it as C raised to alpha is R omega. So R omega T into, you can take y0 common. Y0, A is y0 and B is alpha upon beta y0. So it is, or no need to take y0 common. You can write it as y0 cos beta T plus alpha upon beta y0 sin beta. Got it? This is the equation of y. What is asked in the question? Plot the displacement versus time graph. Can I plot the graph? Can I plot the graph? It's difficult because there are three terms. One is the term of e raised to minus r omega t. Other is cos beta t. And then third is sin beta t. How the graph will be, it is difficult to work out. But you can simplify the bracket. Instead of having two trigonometric terms, you can convert it to one trigonometric term. Can you do it? And to do that, one common treatment is always given in dynamics. And probably the problem that we have solved in part A, and the system is given an initial displacement y0 and initial velocity v0, both, there also that treatment is required. I don't know whether you are done it. Is y0 constant? Is it constant? Can I assume some other constant like E sin gamma? E is constant, gamma is constant. Multiplication of two constants will be a constant. Similarly, is this term constant? I will assume this constant as E cos gamma. Do you agree? Is it acceptable? You can do it. Kashasati, you will realize little later. Assume करायला काय जाते आपल्या बाचं? You can assume. All right, and now substitute. You can say substitute name. By 0 is equal to E sin gamma. And alpha upon beta y0 is E cos gamma. Let me call this equation 3 and this is equation 4. Now, here it will be substituting E sin gamma cos beta t plus E cos gamma sin beta t. But take E common. So you can write y as E into e raised to minus r omega t into bracket sin gamma cos beta t plus cos gamma sin beta t. Sin a plus b. So it will be sin beta t plus gamma. Right, gamma plus beta t or beta t plus gamma. And now you can say, see, now with some logic, can we plot the graph? The graph of displacement versus time, all of you pay attention. I'm going to make an important statement. Try to understand. The graph of displacement versus time is a sine curve first. Now you'll say, sir, what about e raised to minus r omega t? My sine curve is bounded within the curve of e raised to minus r omega t. And I'll first plot the graph of e raised to minus r omega t. This graph is like this. My summation curve is going to be on positive side, negative side, so e raised to minus alpha t I'll plot here also. So this is my graph of e raised to minus r omega t. Within these boundaries, you plot the graph of sin theta. Right? And that graph at t is equal to 0, my y is y0. Do you agree? So my sine curve is going to be like this. So this is the graph of under critical damped case. If I want to present it physically, I've got a single degree of freedom system. Damper is there. You have pulled the system by y0. At t is equal to 0, y is y0. When it goes to negative extreme, it's not going to y0. Y0 is here. Negative y0 is here. But when it goes to negative extreme, its displacement is reduced. When it comes to positive extreme, its displacement is further reduced. And that's how amplitude is reducing and it will come to rest after some time. That's what the interpretation is. Agree? All right. You can plot this graph. We'll work out a little further. Let me call this equation 1. Let us check equation 5 at t is equal to 0. T is equal to 0. Let's say from equation 5, you will get y is equal to e into sine gamma. And what is E sine gamma? From equation 3, why not? Why is it? Is your initial condition satisfied? Okay. Your displacement is maximum here. Next displacement is maximum here. 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 Right. Can you tell me what will be the value of sin theta here? Sin theta is maximum. So theta is going to be pi by 2, 3 pi by 2, 5 pi by 2, and so on. And here sin theta is 0. So it is going to be pi, 2 pi, 3 pi, 4 pi, and so on. Agree? Okay. So you can say from equation 5, amplitude is maximum wherever sine beta t plus gamma is maximum. That is equal to 1. Maximum value of sin theta is 1, no? That is equal to 1. And now it happens, right? It happens at all angles. Beta t plus gamma is pi by 2, 3 pi by 2, 5 pi by 2, and so on. Agree? Okay. And now let us identify the first cycle of vibration from this graph. System is starting from positive extreme, going to negative extreme, and then coming to positive extreme. This is the first cycle. And therefore I can say this time is the period of vibration T. Because that is the first cycle of vibration. And as the system is damped, I call this is T damped. T damped. This angle will be pi. This angle will be pi. And therefore, this angle will be 3 pi by 2. More than 1, right? And then this will be 5 pi by 2. Okay. And now see if you can find out the value of period of vibration from this. I'm trying to prove that beta is omega damped, as we have seen in the beginning today. Beta is omega damped. When this angle is pi, because tan theta is 0, this is 2 pi, this is 3 pi. And therefore, this will be average of these two, that is 5 pi by 2. So I can say that beta t plus gamma, this angle is 5 pi by 2. At this point, 5 pi by 2. Are you getting some clue? How to prove that beta d plus, rather beta is omega d? Let's try in another way. I'll do like this. I'll take this time as say T1 and this time as T2. What is this position? Displacement is 0. System is at neutral position. Now system is, that's physically low. I pull the system now by 0. Fine. Release it. It has come to neutral position. It has gone to negative extreme. Come to the neutral position. Right? Then gone to positive extreme and again coming to neutral position. That is one cycle, I can say. Coming from neutral position, going to negative extreme, then going to positive extreme and coming back to neutral position will be one complete cycle. For one cycle, it has to pass through neutral position twice. Right? And now T2 minus T1 is, I can say, the period of perturbation, damp period of perturbation, TD. I can do like this. Agree? Okay. And now I think we are in a position to work out. Here at T1, beta T1 plus gamma is equal to pi. Do we agree? Sin pi 0. And similarly, beta T2 plus gamma is 2 pi. Let me call this equation 6. This is equation 7. Let's work equation 7 minus equation 6. Yes, you are right. 3 pi. Right? So each term will be subtracted. This will be beta T2 minus beta T1. You can subtract left hand side and subtract right hand side. Or if you want to operate, as you are subtracting this equation, this term will be minus, this will be minus, this will be minus. So this beta T2 minus beta T1, gamma minus gamma will cancel. 3 pi minus pi is 2 pi. And now you can take beta common. You will get T2 minus T1. And what is T2 minus T1? TD. Damp period is 2 pi. And therefore T damped is 2 pi on beta. Right. Now comparing this equation with the equation T is equal to 2 pi upon omega. Let's say comparing this equation with the equation of T is equal to 2 pi upon omega. What is the conclusion? Omega is equal to beta. And as it is T damped, I call it as omega damped. Like this equation. If I want to compare with T damped, it will be omega damped. Thus, we have proved that beta is equal to omega damped. And we have derived equation of beta. We have simplified. It is, I think, omega into under root 1 minus r square. It's a very, very important equation. When the system is damped, the natural frequency of vibration is reduced by the term under root 1 minus r square. Omega into under root 1 minus r square. Right? And from this you can say, if you want to find out the period, T damped is equal to 2 pi upon omega damped. Right? Okay. Let's draw one important conclusion of dynamics from this simple equation. For masonry structures, what is R? 10%. So you can say for masonry structures, R is equal to 10%. That is 0.1. Let's call this equation 8. Substituting in equation 8, see what you get. Omega damped is equal to omega into root 1 minus 0.1 square. So 1 minus 0.1 square is 0.01, and it is 1 minus 0.01 is root 0.99. So root 0.99 is 0.99. 99. Okay. So what's the conclusion? Even if you take highest structural damping, even then the natural frequency of vibration is not much affected. Not much affected. So in civil engineering, presence of damping is not going to affect the natural frequency. It's not going to affect the natural field also. If omega damped is not affected, T damped will also be same as the natural frequency of undamped system. So I can say omega damped is approximately equal to omega for all structures, and T damped is approximately equal to P for all structures. Very, very important conclusion. To complete this derivation now, equation 2 can be rewritten as see, in equation 2 we have got alpha and beta, so we have to write the values of alpha and beta. Y is equal to e raised to minus r omega t. Is it? Alpha is r omega, we approved. A cos theta, may I say it is omega damped? A cos omega dt plus b sin omega dt. Very, very useful equation. Solution of differential equation. I call this as equation 9. You have to always use this equation here after. Okay. So with this now let's go to the next point from the list I have given. What is the next point? I think it is logarithmic decrement. So give a title, logarithmic decrement. It's a damn single degree of freedom system. I have given initial displacement by 0. I have pulled it, released. If you go to negative extreme, here it is. And then it will come to a next positive extreme, which is less than y0. Again, it will go to negative extreme from here, come to next positive extreme, which is still less than the earlier value. And that's how the amplitude is going to use. Let me call, if this is y0, let me call this as y0. After the reduction in amplitude after the first cycle, y2, y3, and so on. Every time maximum amplitude is reducing, because of presence of damping. Now logarithmic decrement delta is defined as the natural log, that means log to the base e, of the ratio of two successive peak amplitudes y1 upon y2 on the same side. or y2 upon y3 on the same side, positive side. That is called logarithmic decrement. So you can note it. Logarithmic decrement is defined as the natural log there are two logs. One is log to the base 10 and one is log to the base e. Log to the base e is called natural log. And on your calculator, it is indicated by ln or in, whatever it may be. Right? So logarithmic decrement is defined as the natural log of the ratio of two successive peak amplitudes on the same side of neutral position. On the same side of neutral position. On the same side of neutral position. Two successive peak amplitudes on the same side of neutral position. But I need to say here, see, after first cycle it has come to y1, that is here. In the second cycle, it starts from y1, go to neutral position, go to negative side. I am not taking ratio of this and this because they are not on the same side of neutral position. One is positive, other is negative. I am not taking that. When it comes back to the positive side, then you are taking the ratio. That means after every one complete cycle, you are taking the ratio. That is logarithmic decrement. Right. Okay. All right. And now you plot this graph again. Plot it again. At y1, I call the time as t1. And at y2, I call the time as t2. Again, t2 minus t1 is t down. I am required to complete one cycle of vibration. All of you just see y1, y2, y3 are the peak amplitudes. At every peak amplitudes, sin theta is maximum. You can say y1, y2, y3, etc. are the peak amplitudes where sin theta is maximum. Full stop. Therefore, from equation 5, what will be equation of y1? So that I can write this E into e raised to minus r omega t1 or y1, the time is t1, into sin theta is 1. Similarly, what will be y2? E raised to minus r omega t2 into 1. If I take y1 upon y2, you can do it on the next line. Y1 upon y2 is this upon this, you will get x. Now let's say substituting in the equation of logarithmic decrement. Substituting in the equation of logarithmic decrement. Delta is equal to log to the base e raised to minus r omega t1 or e raised to minus r omega t2. Log of a upon b is log a minus log b, right? So it will be log to the base e raised to minus r omega t1 minus log to the base e raised to minus. Log to the base e raised to something. It is anti-log. So it will be simply minus r omega t1. First of all. Do you want to check? Check on your calculator. ln in the bracket e raised to 2. ln in the bracket e raised to 2. What it is? 2. Check calculator. Also कर सकता हूँ. Right. Let's go. Why you are not doing? Why you are so one? Okay. But gड़बड़ चली है ना. थोड़ा सा you are looking demand for last few lectures and you are absent also. Oh, right. Yes. ln e raised to 2. ln in the bracket e raised to 2. You should get the answer 2. उठेगा, है? Okay? Yes, yes sir. ln e raised to 2. This option x is to 1. So ln e raised to minus r omega t1 is minus r omega t1 minus this minus in the bracket it will be minus r omega t2. असं जर कॅल्क्युलेट केलं तर काय बाबा सर सांगतात ते खरं असं वाटतंय ना कुठेतरी दिसतंय आपल्याला चलो बरं वाटतं मजा येते नाही तर काय हे सर सांगतायत आपण लिहितोय आहे का नाही खरंच सरांना माहित देवाला माहित सो प्लीज डू इट तुमच्याकडे इतक्या ample avenues are there with you, you are not utilizing it. Your generation is very lucky. In nowadays, we never used to get even books also, proper books. That was the scenario. Forget about internet. Calculator was there, fine. But books, internet, information, nothing there. Your generation is lucky, utilize it. And your concept should be more clear than us. Everything you can see, verify. Right? Okay. And so you will get delta is equal to let take r omega common. So it is minus minus is plus. And then write this equation as t2 minus t. T2 minus t1 is t. So it is r omega into t. Now substitute the equation of Td that we have derived. Delta is equal to r omega Td is 2 pi upon omega dash. That is equal to r omega into 2 pi on omega dash is omega into under root 1 minus r square. Right. This omega will be cancelled. And you get another equation for logarithmic increment delta as 2 pi r upon under root 1 minus r square. Okay. So what is logarithmic increment? Natural law of the ratio of y1 upon y2. y1 upon y2. Even you can take y2 upon y3. Same ratio you will get. y3 upon y4. Same. Two successive p-computers. Any two successive p-computers. So it will be yn upon yn minus 1. With earlier is the logarithmic decrement. And it is given by, it is constant. So one more interesting conclusion. Every time the reduction is for a given value of r, logarithmic decrement is constant. By the constant percentage, the amplitude is reduced. And the system will come to rest. Right? So we'll stop here for today. Monday we'll try to finish this topic. Today is 13. This number 1 Bhatkar is there. Kurgaonkar is there. Number 2.
Yes, sir, he is present.
Satputi. Number 3. Absent. Zina.
Present, 4. Sir.
Okay. Roll number 5.
Present, sir.
Okay. Roll number
Yes,
5.
sir, present.
6.
Present.
Present. 6. Gore. Okay. Panjre is here. Metapoli is here. Inamdar. Roll number 10, Sayyid. 11, Pawar. 12, Band. 13, Sasne. So option numbers are 3, 10, 11, 12, 13. As I told you, in the problem that I given you, they are locked out. Listen, the labors are given. Yes. Okay. With the problem that I given you in undamped systems, the system is given initial displacement y0, initial velocity v0. I think you have derived the equation of y as y0 cos omega t y v0 upon omega sin omega t. Plotting this graph is again difficult because there are two trigonometric functions, cos theta and sin theta. So why you have plotted the graph like a sin theta? The reason is again same simplification. You can assume this y0 is E sin gamma and then v0 upon omega is E cos gamma. And now you can say y is equal to E sin omega t. See, it is E sin gamma cos omega t plus E cos gamma sin omega t. Do it. Take E common. Do it in that assignment. So it is E sin omega t plus gamma. And now you can say your graph of is a graph of sine curve. At t equal to 0, y is E sin t is equal to 0, E sin gamma. And E sin gamma is nothing but y0. And therefore, if you plot the graph in that problem, t is equal to 0, y is y0. The system is having initial velocity. That's how the graph is like this. It's an undamped system amplitude. Maximum amplitude, whatever you get, is going to remain constant. Undamped system is. And what is the maximum amplitude? Y0 is not maximum amplitude. This equation can help you to find out maximum amplitude. Maximum amplitude is when sine is 1, that is E. So you can say maximum amplitude is E. Now how will you get E? See, y0 is E sin gamma that I am assuming. and V0 upon omega is E cos delta. If you want to find E, I'll call this equation 1, small 1. This equation is small 2. Because in that problem, we might have used some other equations, numbers. Squaring and adding equations 1 and 2. Squaring and adding equations 1 and 2. We get y0 square is equal to e square sin square 1. Do it on the next line. Similarly, v0 upon omega bracket square is equal to e square cos square 1. Square and then add them. This equation plus this equation. So you have to add left hand side and right hand side independently. Y0 square is plus V0 upon omega square. You may take E square common on the right hand side. Do it. So what you will get? Is equal to 1. And from there you will get E is equal to the root. Do it. Metaphorically, why you are not doing? कंटाळा आला का? दोन नंतर काही सुचत नाही. It's lunch time. तुमच्या तब्येतीकडे बघून वाटतं मला. You don't miss your lunch. Come on, then. That's it. Y0 square plus V0 upon omega square. That's how you can do it. So maximum amplitude is here, E, which is more than V0. Similarly, if you want to find gamma, another constant, how will you do it? Divide equation 1 by 2. So, dividing to find gamma, dividing equation 1 by 2. You will get tan gamma. Another E sin gamma upon E cos gamma is equal to V0 upon Y0 upon V0 upon omega. You will get cancelled. Tan gamma is Y0 upon V0 upon. Right? So this solve. You have to solve that problem. Okay. Alright, please complete all assignments and show me on Monday. Monday first I will check the assignments. We'll stop here.
So for this velocity versus time graph, when will start from bottom, when will start from positive side and negative side?
What is the equation of your velocity? So use this equation. From this equation, you can derive equation of velocity also. I think you will be is E omega cos omega t plus 1. Right? So the graph of y dot is also cos theta and it's on positive side. And at t is equal to 0, y dot is e omega cos gamma. And e cos gamma is v0 upon omega. So it will be omega into v0 upon omega. It will get cancelled. So it is v0. At t is equal to 0, y dot is v0 and that is on positive side. The sign code, right? And as t increases, the graph will be something like this. Why on negative side you are plotting? Yes. Probably when you convert this equation to this form, you are in a position to plot the graph properly. With this form, whether to go by sin theta graph, cos theta graph, it's not possible for us to decide. That's why this conversion is required. Got it? So please understand this problem thoroughly and do it and show me on Monday. We'll stop. You can meet on Monday at 12:50. Anything else? No. This is the equation of displacement y is y0 plus omega t. V0 upon omega sin. You know y0, you know v0, substitute t is equal to 1. And use radian. Then only you will get the difference. So it's not getting an exact answer except because minus use radian. And then to find the equation of velocity, you are right, you are taking derivative of this. So you can use radian, you should get it. Right? In dynamics, you should always use radian when you are covering cos omega t. See, omega is in radian per second into time t. So radian per second into second is radian. That angle is always in radian, not in degrees. That's why. Got it? So you have to be radian. Yes,